Hello. Let's move on to our next section. After we finish this section, you'll have a Google quiz that you'll need to take to assess how we did with these two topics. So now we're going to do something a little bit different. We are going to basically work backwards. We're going to do the opposite of distributive property to allow us to divide, to break things down instead of multiplying them. So, I'm not sure. Okay, so we're going to factor, which means we're going to break things down into what they would have looked like before we FOILed them or used distribution. So we start with distribution because it's just a little bit easier. So what factoring does is we're going to take a polynomial like this 27y squared plus 18y, and we're going to break it down into the product, which means we're going to have it as a multiplication problem instead of a final polynomial. It's going to be the product of a monomial. It really should say one monomial and a polynomial. So we're going to turn it into one monomial and one polynomial, which might have two terms, it might have three. It just depends on how this product, how the problem is set up. So I kind of want to, there we go, and a polynomial. So factoring is the reverse of one of two things. Either, oh dear, that's what I meant, distribution, which is when we take something, and remember we kind of draw our arrows, so something into two different terms, or we can think of it as multiplication. We can think of it as either way. So it's not saying one or the other, it's saying we can think of it as the reverse of distribution or the reverse of a multiplication. We're going to create something, and then if we multiply it back out, we can check it and make sure it's right. Okay, so not really a new term, but maybe something that you haven't seen in a while. We have to start all of these problems by finding the GCF, or if you recall, that stands for greatest, oh my, greatest common factor. We're going to find the GCF of every term in the expression. So this first problem we're going to do has two terms. We're going to write the GCF of each term. Okay, so I don't know. I'm going to jump back and forth between the PDF because we're going to make factor trees. So we're going to start by saying, okay, we have to write 27y squared as factored form. So we're going to take this and write this equals, we're going to write out its factors, and we're going to do the same thing for 18y, and then we're going to compare them and find the GCF. And the easiest way to think about the numbers is to create a factor tree. So I think for that I'm going to have to come over into the PDF. Okay, so let's be able to comment here. So for all of these problems, here are our steps. So we're going to kind of have to go back and forth a little bit. But first we're going to create the prime factorization for each term, which means you're going to make a factor tree and expand the variables. Okay, that's what we're going to do first. So for 27y squared, we have to make a factor tree for 27. Okay, so 27, how do I get 27? Well, I know I can get 27 with 9 and 3, and 9 is 3 and 3. So my factorizations, I have 1, 2, 3 3's. Okay, so you kind of have to go back and forth with me here. 27 will be 3 times 3, 3 times 3. I'm going to make them a little wider. Times 3, and then we have to expand our variables. How many variables do I have? I have a y, and a y squared means I have 2. So y times y. Okay, so we're going to write out that, and we have to break down 18y. So let's make a factor tree for 18. 18, what is my multiplication fact there? That's 9 times 2, or 3, 3, and 2. So 3, 3, and 2, that's my prime factorization for 18. So I have to write 2 times 3 times 3. And what variables do I have? Just one y. Okay, so that was my first step, is creating this prime factorization. Then we're going to write the GCF. So to find the GCF, it's my second step. Find your common factors. And the best thing to do here is circle these. Okay, we're creating our GCF by circling our common factors, which I'm not sure I can do in here, but let me see what I can do. Bear with me.